Hello. Let's start with another devlog, and yeah, I'm going to continue where I left off the day before yesterday. So far, we have created a readline query, and here, sorry, a readline function, and here we are using a buffer, and that buffer can be passed in. Whenever somebody calls it. Of course, this is not going to be compiled. I think I changed it a little bit. Actually, it's compiling. Am I? No, that's because it wasn't saved. Yeah, this was the last error we saw. We couldn't pass a buffer with defined size of 16 bits into the function that doesn't expect that, so we need to hard code this here, and then now it's compiled, right? So I wanted to build on top of it. I had some requirements. Yeah, as I said, I wanted to make it more flexible. So I searched for different options, and one of the solutions that I could use is to use a memory allocator and heap, basically. And when the function accepts an allocator, the user has different options to how to utilize it. Just for note, this is my uncharted territory, right? Whatever I'm going to cover in this video is not something I've done before. I find my knowledge here not that deep, so feel free to let me know if I'm making a mistake, my assumptions are wrong. This is something I'm still learning, right? So that being said, the first thing I can do here is to ask the buffer to pass in an allocator, and that allocator could be of type std mem allocator. It's, I think, capital, right? And then from here I can do actually I don't want Copilot to be enabled here. Please disable it. Yeah. So then for the buffer, I can have the buffer. Actually, it should be const. I'm looking up my actual code over there. So I solved this problem once. I want to go over it here and describe what I learned from it. So then buffer can be allocator done. Actually, it should be tried, I believe. Allocator that alloc, and there is a comp type, comp time type that I need to define, which is basically U8 in our case, and then a size, which for now I'm going to set it to 1024, and I think this should be fine, right? Then there are two different types of allocators actually that I can use. Let me actually Zigling allocators, see what allocators are available in the documentation. Allocators, I have page allocator, fixed buffer allocator, and all of these are different in the usage. For example, there is this general allocator which you need to deallocate the allocator itself, but also make sure that you free up every byte inside the allocator before exiting. This is I think very in terms of memory management, very clean, right? You are in charge of every bit of memory that you're using, but this is also very hard to use. For example, if we have, actually, let me do this, right? Probably this is easier to show. If inside the function I want to use this allocator for every reader that I have, for example here, right? I need to have something like this, right? And then here I'm initializing the allocator. Then I need to also defer allocator deinit. I think it was what was it called? Let me quickly check. It was, yeah, deinit by, I'm not, oh, it's GPA, right? Deinit. And then here I'm deallocating it. Then in the usage here, I need to basically pass in the allocator. This should be fine. Then I don't need this one anymore, right? But what I need to do is also take care of ferrying the memory, right? Which is, yeah, kind of ugly and I don't like it. An easy way, but more which uses more memory in general, probably as not optimized as general heap, general purpose allocator, is to use an arena allocator, which takes in page allocator on heap, provides as much memory as your logic needs, and when it deallocates, it will deallocate the memory altogether. So clean it up after itself automatically, but it's not as optimized and is not as manageable by the developer. So, but in this case, I think it kind of makes sense to use this allocator, and that's what I'm going to use. Or allocator, and then maybe, yeah, go here, and lot rename it. Yeah, that's better. What I need to name it, I'm going to call it arena. Right now I have the allocator. I'm passing in the allocator. Let's see if this one compiles. There is an error. Oh, I think the arena allocator function call is different. Oh yes, I should have passed the page allocator to it. So it would be std heap dot page allocator. Just the amount of things I need to remember is this type is not a function. Oh yes, it has an initializer. Expected type. It's now failing on line 36. Yes, I'm not passing in instance of it. Yeah, the function is not, I skipped an extra one. So I'm going to change this and also to this, change it to allocator. Okay, now it's changed. I think I need to change everywhere. That's fine. Remove this, go to GS and put allocator here. Do I have another red line? Red line. I think these three are what I needed. And then I can run my calculator. 1 plus 3. Yeah, I'm getting what I need. So yeah, this is it. And then there is of course this integer value that I'm hard coding here, but I can also choose to make it customizable by the user, which I think would be easier to use. So I'm going to do that as well. And yeah, basically take in integer. I think use size is the type we use for the sizes, right? And now in each grid line, we need to pass in that 16. I think yeah, 16, and then R3, 16. Good. Now it compiles. Good. So the next step, which I'm going to cover after a short pause, is to refactor this part, which is still using the deprecated writer. Here, this reimplementation will push me beyond, even more beyond my skill sets. There are some concepts I just learned generally to satisfy my need on this rewrite, but I need to spend more time and go deeper in details for them. Things like I don't know how comp time types work and how you define such functions. Things like why these initializer functions are written like this. You know, this is some part down to the design of the language, and not having a recursion, heap allocated recursion in Zig. I don't even know how it is implemented, heap allocated recursion, but I was using it in other languages, like high-level languages like Python and JS. It was easy and convenient to use, but I wanted to re-implement the same pattern here, and it wasn't as easy. So I'm going to take a short pause. I need to bring myself some water, and then I get back to that re-implementation.
But speaking of progress,
Okay, I'm back. So let's rewrite this to learn this concept. Actually, after my previous stream, I was thinking about how I'm going to do it because I had spent some time to learn this rewrite previously, and ended up that in a situation that I couldn't use a print statement, right? Where I needed to format some values, I think, down here, right? What I was doing was actually using the std debug print statement, which wasn't actually printing it in the stdout the way I liked it. So I wanted to find a final solution, actually final design on how uh, this new pattern should be implemented instead of this deprecated. And while thinking about that, I was also watching this nice Zig release note video by Cybert, and then uh, he mentioned this part of the release note, which somehow I didn't see when I was basically reading the release note. But that helped a lot. Just the reiteration here, I think it's better to show it as the FS file rewrite. Yes, this is the one I want. And down here, they have an example. Basically, what you need to do is to define a buffer, pass it to your writer, and then use this interface. I think Andrew Kelly had another talk, which I'm going to link in the video, about why this interface is used and what is the idea behind it, and why you need to flush everything basically using this interface. This is necessary. I'm going to demonstrate what this means, but it was kind of annoying, then pushed me down to a path that I needed to re-implement it in a function that doesn't need me to every time flush when I want to print something. So let's go back to code. Basically, what I learned from the release note is that, of course, I need a buffer again, and that buffer is going to be of size 16 U8. Actually, let's make it bigger, 1024. The size, if we exceed this size, nothing drastic is going to happen, but the thing is, the chunk of the print needs another flush for it to basically show it on the screen. So it won't be as efficient if we make the chunk to a small 1024. In my case, at least, I don't see any reason that I'm going to exceed it. If I use ASCII characters, 1024, I think it's in bytes, and that means, yeah, it's in bytes, right? I'm saying that it's a U8, then it's a byte, right? 1024 bytes, it means I can use this amount ASCII character or half of it as a Unicode character. So with that being said, let's do this implementation, and then here, instead of deprecated, I'm going to use writer and pass the buffer to it. Actually, this buffer should be variable because I'm going to assign to it, right? It's not currently assigned. This I can remove. I have the writer. What I need is actually to take the interface of the writer, right? But now there is a problem. If I use stdout.print and do basically this. I want to do the same here too. And if I zig build run, let's see what is there first. Expected pointer to IO writer. I'm passing a constant IO writer to it. Where is this happening? Is this because of it? Let's make this a variable, right? And then only so std.out. Let's call it out writer, and then std.out is equal to outWriter.interface. And oh yes, now I need to get a pointer of it, right? I think that was the case. Let me quickly check. Yeah, I need to get a pointer of it, and there I can get the interface. I'm still not sure why this is happening, that I need to use a variable for this and then point to its pointer. Probably the return type of this function is causing that. Anyways, to simplify it, I'm going to just repeat this pattern because there are more details that I need to cover before getting too deep into why this pointer pattern is defined like this. And now if I run it again, what happens is my application is running, but it's not printing what I needed. To solve this, I need to basically do stdout dot flush, and this flush is going to print. Did I make a mistake here? Self.writer flush. Again, back to reference. stdout is the interface. Oh, I need to try it. Yeah. Yeah, it's also saying it here as well. Yeah, now it works. Cool. So this was good, kinda, but since I'm using too many prints all over places, I needed to flush every time. I couldn't do it at the end only because I'm also interrupting the program to take in the user input, and those messages are kind of important here, right? I had many iterations of this implementation, but I'm going to just cover the final implementation that makes the use of these print statements a little bit easier. Basically, what I'm doing here is I'm not even sure if that's the right pattern for me to use. Probably there should be easier way to print to stdout. But yeah, I learned a few stuff here, so I want to just share it here. And yeah, feel free to let me know if there is a more developer friendly way of printing out without messing up with the memory too much. Anyways, the first thing I need to do is basically make sure that I need to define a function, right? And what I want to have in this function, let me do it from outside in, right? What I need to do here is I'm going to call this function right. The reason we will figure out quite soon. And then in this writer function, I want to basically return nothing. I might have some errors, but what I need to do is to first print. So here I will have my fmt, which is an array of u8, and then args of any type, right? And then I pass it to this. But what I also need is to flush this. So this print doesn't exist. For now, I'm going to consider this called writer, and writer, but probably I need to change it again as well. This is fine, but if I want to use the same function for std in, right, or sorry, std error, or a different kind of files, right? So this type is currently unknown. I cannot have a specific type to mention for this writer, so I cannot take it in here. What I need to do instead is to use comp time and make sure this type is known on compilation time. So the user, when the user of the function defines that type, that's passed to this definition that I have here in compilation time. So the final design I came up with is to basically have a printer, and then here I'm going to take in that type. I'm calling it comp time. What is it called? Writer type, and I'm going to call it type and then type, right? One caveat here is if my function is returning a type, anything inside this argument list should also be known in compilation time. So for example, I cannot pass in fmt and args to this function and make my life easier. It's not possible. Everything related to this should be also known in comp time. So that's why I need this closure thingy to happen, but Zig doesn't support it. However, there is a variant of it that it supports, and that's returning an struct, right? And inside this struct, I think we learned in the in our Ziglings that we could return a function, right? And here I'm going to use an object-oriented like pattern to provide this writer based on this writer type to this function. So whenever I call this function as the output of my printer, it will have access to that writer. So what I'm going to do is to add a key of writer type. Here there is no pointer, that's it. And down here I'm going to call self. The type of this self would be this, so basically this struct, and then I can call self.writer, please, and self.writer. Right now, the thing is how I'm going to initialize this class. Again, I'm calling it class, but it's a struct, right? In Z. It behaves just like a class in object orientation. How I'm going to initialize it is also a little bit tricky, because I not only need to pass the writer to this, writer type to this, but I also need the writer object itself. So it will make sense in a few minutes when I'm going to use it, but it is not again possible. Again, the rule I said, every type here should be known in compilation type, but the object of the stdout is only created in the runtime. So to overcome this, I need to define another function. My first version had a separate function here. I was calling it make printer, and then the type over here I was using a writer type, and it wasn't as beautiful as usually the Zig implementations are. And then I learned, okay, one pattern they use a lot is having an init function here. And then for that, I had this writer of writer type, right? And then the return value would be this. And then what it returns is basically this object, right? I'm using this pattern. Basically, it will cast whatever I'm going to create to this, because the return type of this function is this, and just set the writer value to the writer I'm passing to it, right? This way, I first need to initialize this writer, pass in the writer type being an stdout, std error, whatever, and then it will set it here, and then I can write, and it will automatically flush every time I'm using it. So basically, what needs to happen is that I do a const printer is equal to printer printer, yeah, and then it's type of stdout, right? And then I initialize it with the stdout object itself. So first, the here I'm passing in the type of the object as the to the compilation time writer type that this function needs. Then I'm passing the writer itself to this initializer, so it will be available in this struct, so I can use it. This is how basically type safety enforcing me to know this time ahead of this type ahead of time. So now I think I can undo replace stdout.print to what I had here, printer.write. Yes, both of them. And then drop this flush. This shouldn't be necessary anymore. So I hope this time it works. No. I'm expecting line 47. I'm expecting a time a few 8. What mistake did I do? Yeah. Oh, okay. It expected to be constant. Does it need to be a pointer as well? No. Let's try it again. Unable to resolve comp type value. Okay, one thing I missed here is this try. Oh, the error type is also not known here. Let me use any error that might happen. unable to resolve comp type value of this FMT. Should it be comp type? Oh yes, yeah, this value FMT should be comp type known. Otherwise this doesn't accept it, right? Oh yeah, here it says the input value is comp type known. So zig build from. Beautiful. Now it works. I don't need to have an extra flush here. Was it the easiest way to do it? Probably not. I'm not sure if this is the right pattern, but it pushed me to, yeah, basically have my first experience with regards to some details, like how a basic recursion can happen. Basically, have a function that returns a function that I can use, but initializes it. I learned about this. I learned a little bit about comp time, how does it work, and this criteria that when you have a return type of type, you cannot have arguments that are not known in comp time. I also learned about this any error. This is also important. I think when I tried it, let's try it without this. I didn't get an error, but in one of my tryouts, I had this problem that the compiler was nagging about. This error type should also be known in compilation time. I think I was using a pattern where I had the return type together with mixed up with the function, and there were many errors in it. It was just one of them. So to solve that, I needed to also indicate the return error type. Any error is like just any type, which I'm using here, and potentially we can do better, I think. But I think for the error, for the prints, they are all the same. I'm not sure if it's the case. FMT is that, yeah, for the print, the Zig language itself is using any type, so that's fine. I'm using it here as well. But there are ways to also be more specific. So you can have, I think, something like any error, and then inside it, define what exact error that you expect to get. Anyways, that was it. Yeah, starting tomorrow, I'm going to go back to my initial routine and continue with Ziglings. But this exercise was quite a reasonable stretch out of my comfort zone to basically get a taste of how writing such a simple program in a low-level language like Zig would look like. Thanks to writer of this article. I changed a lot of things from it, but I also learned some basic stuff. And I think I'm going to do more of these kind of tutorials, which off camera I'm going to yeah, basically learn some more details and then share it over here. Yeah, let me know what do you think about it. Feel free to like and subscribe, and yeah, see you around.